Welcome, developers. Today we are diving into LangChain Expression Language, or LCL, and unraveling the immense power of declarative chains. Let's get started. Let's kick things off by defining what LCL actually is. LangChain Expression Language, or LCL for short, is a declarative way to compose different LangChain components. In traditional, imperative software development, you write explicit, sequential steps dictating exactly how data should move and how functions should execute. LCL flips that on its head. Inspired by Unix pipes, it allows you to declare what you want to happen by chaining components together using a simple pipe operator. You just say, take this prompt, pipe it to this model, and pipe that to a parser. The framework handles the heavy lifting of passing the data along, managing the state, and executing the sequence. This approach drastically reduces boilerplate code, making your AI architectures incredibly clean, readable, and modular. Looking at this diagram, you can see the fundamental shift. On the top, we transition from messy imperative code to clean declarative chains. On the bottom, we visualize the core mechanic of LCL. Data flows seamlessly from a prompt, through a pipe operator, directly into a large language model, and then pipes right into an output parser. Each node is autonomous, yet perfectly connected. To understand how LCL works, we have to look at its foundation, the runnable interface. You can think of the runnable interface as the universal plug that makes all LangChain components compatible. Whether it is a prompt template, a language model, a document retriever, or a custom Python function, if it is built with LCL, it is a runnable. This interface mandates a standardized set of methods. Need a single output? Use invoke. Need to process many inputs at once? Use batch. Want real-time generation? Use stream. And because modern web applications require non-blocking code, every single one of these methods has an asynchronous equivalent, like invoke and a stream. This uniformity is the secret sauce. It means you can swap a local model for a cloud model, or change your parser, and the surrounding chain doesn't need to be rewritten because everything speaks the exact same language. This diagram illustrates the runnable interface as the central hub. Any LangChain component flows into this interface, which then branches out into our standardized execution methods. Notice how synchronous methods like invoke, batch, and stream are perfectly mirrored by their async counterparts on the same nodes. It is a unified standard for execution. So, why should you adopt declarative chains over traditional coding? The benefits are massive for production systems. First, it enables rapid prototyping. You construct complex AI pipelines in just a fraction of the code. But the real magic happens at runtime. By declaring your chain, LangChain automatically optimizes execution. For example, if you have independent steps, LCL executes them in parallel automatically, drastically cutting down latency. Furthermore, declarative chains provide automatic streaming. Instead of waiting for a massive response to generate, LCL streams tokens as they are produced, giving your users a highly responsive experience. Lastly, because the framework knows the exact structure of your chain, it integrates seamlessly with LangSmith. This means you get out-of-the-box tracing, debugging, and observability without having to instrument every single function call manually. You get enterprise-grade features for free. Here we break down the four main pillars of LCL benefits radiating from the center. Top to bottom, we have auto-streaming for better UX, parallel execution for speed, LangSmith tracing for deep observability, and code reduction for maintainability. By simply using the pipe operator, your application inherits all four of these enterprise capabilities instantly. Let us get practical and look at how you actually write a declarative chain. It is beautifully simple. First, you define your prompt template with your input variables. Say, tell me a joke about a specific topic. Next, you initialize your chosen language model, and then you set up an output parser, like str output parser, which simply extracts the raw string from the model's complex message object. Step 4 is where LCL shines. You simply assign a variable, let us call it chain, and set it equal to prompt pipe LLM pipe parser. That is it. The pipeline is constructed. To run it, you call chain.invoke and pass in a dictionary containing your variables, like setting topic, to artificial intelligence. The dictionary flows into the prompt, the formatted prompt flows into the LLM, and the AI message flows into the parser, returning a clean, plain text joke. This linear flowchart perfectly mirrors the line of code we just discussed. We start on the left with our input dictionary. It flows into the prompt template, which outputs a formatted string. That string enters the LLM, which outputs a complex AI message object. Finally, the str output parser strips away the metadata and outputs the plain text result on the right. Let us take a deep dive into the underlying mechanics. How does the pipe operator actually work? It is not just syntax. It is leveraging Python's magic dunder methods, specifically OR and ROR. When you write component A pipe component B, Python executes a .or B, LangChain intercepts this, and dynamically creates a new object called a runnable sequence. This sequence acts as a sophisticated orchestrator. It ensures strict data marshalling, meaning it validates that the output schema of component A perfectly matches the input schema expected by component B. If there is a mismatch, it throws an error before the execution even begins, saving you from runtime bugs. Furthermore, if you pipe a standard Python dictionary or a regular Lambda function into the chain, the runnable sequence automatically wraps them into runnable objects behind the scenes, ensuring the chain remains unbroken and fully compatible. In this technical breakdown, we see component A and component B converging on the pipe operator. This triggers Python's internal OR method. The result of this operation is the instantiation of a runnable sequence. This sequence then moves down to the final, critical step, strict schema validation and managed execution. As your applications grow, linear chains won't be enough. You need advanced data manipulation. This is where components like Runnable Lambda and Runnable Passthrough come in. Runnable Lambda lets you inject any custom Python function directly into your declarative pipeline. Need to format a date or clean up some text, just wrap it in a Lambda and pipe it in. Runnable Passthrough is incredibly powerful for managing state. It allows you to pass initial input straight through the chain unchanged, or you can use its .assign method to append new generated data to your existing dictionary of variables. You can also build complex branching logic. By using a dictionary mapping inside your pipeline, you can route the same input to multiple different chains simultaneously. LangChain will execute these parallel branches concurrently, drastically optimizing the total processing time of your AI workload. Observe the branching in this diagram. The input query hits a parallel dictionary and splits. One path goes into a story generator, while the other uses runnable passthrough to carry the original input forward. Both paths converge into an aggregated output, which then feeds perfectly into a final analysis chain. This is true advanced routing. Let us tie this all together with a real-time, highly helpful use case. Imagine a marketing agency that needs to generate thousands of blog posts based on trending topics. But they also need to guarantee that the generated content aligns with a specific, positive brand mood. Using LCEL, we can build a two-stage pipeline. The first declarative chain takes a topic and generates the story. We then use runnable passthrough.assign to take that generated story and pipe it directly into a second analysis chain that evaluates the text's mood. In a single invocation, the system generates the content, analyzes its own output, and returns a structured dictionary with both the story and the mood score. This eliminates manual review, scales infinitely, and takes only a few lines of declarative code, proving that LCEL is a massive force multiplier for AI engineers. I hope this deep dive transformed how you view LangChain. I want to formally invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram shows the exact business flow. The topic, AI startups, feeds the story chain. The output hits our assign function, holding onto the story while passing it into the analysis chain. The pipeline concludes by outputting a comprehensive JSON object containing both the creative content and the critical mood analysis metrics. A perfect, production-ready declarative chain.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice papers paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.